Good. All right, guys, this is Mr. Hayden. I'm turning this towards me, remember? Just to make sure you can hear me on the internet. All right, so week 4. You excited? Countdown to week 20, 15 more weeks and you're at school. We have summer break. No one's counting, but I am. So we have, well, I know week 3. This is week 4, okay? Don't even worry about that. That's 3 right there. I'm still stuck in the past. All right, so it's week 4. I hope. We'll see as I keep going. All right. You want to go and click next for me? Okay, yeah, this is the right week. Okay, do me a favor. What I'd like you to do is I'd like you to write down the essential question. Now, the essential question for this week is kind of looking at the analysis between these 3 main people. These 3 main people for this week talking about gas and gas law, okay? So gas is going to basically act a certain way. We kind of wrote this a little bit last week with the whole pressure. You guys saw a little bit of like the, not just the vocab for it, but you saw what they actually did. And you saw a little bit of the mathematics. We're actually getting more into the math of this today. So you can actually see how they're going to give you the formula for the test and for everything you understand. You good? What do you need? Of course, yeah. No, don't miss it at all. You don't mind it. All right, so the essential question for today is going to be, what are the differences between Boyle's law, what was that, Charles' law, and Gay-Lussac's law? And you want to look at that and figure out, what we're going to figure out today, what each one of them kind of focus on, because each one of them focus on different things. All right? Take as much as you need. All right, so we're good. So we can go ahead and move forward. All right, so we're going to be talking about gases. Now, in Boyle's law, this gentleman basically talking about pressure and volume. So he's talking about pressure and volume. What is he not talking about? What is he not talking about? Temperature. Okay, that's important. So when you talk about Boyle's law, he's talking about pressure. He's talking about volume. What he did when he did all of his different scientific mathematics and all that, he kept the temperature the same. So he basically used that as a control and got rid of that as an issue. So again, gas is going to be talking about pressure and volume. So when you see any type of question about this, even if it doesn't say, okay, using Boyle's law, blah, 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 it'll actually give you a P1, a P2, a V1, and a V2, and those are the actual things that you need to build an input to be able to get the correct answer, and we'll see that. So, Boyle's law states that pressure of a gas is inversely related to its volume. So, what happens is, if you take this piston and you push it down, as you increase pressure, what do you do to the atmosphere? You go up or down? Here you go. Think about this. Volume is 4 liters. Okay, pressure inside of it, remember we're talking about pressure and volume, is 1 atmosphere. What happens when you push the piston down? You change the volume, what happens to the pressure? Inversely related. As it goes down, it goes up. As one goes down, the other one does. They go against each other, basically. They're not directly related, they're inversely related to each other. So example, if volume increases, the pressure, if volume decreases, the pressure increases. If the volume increases, the pressure decreases. They go against each other. Cool. So there's Boyle's law. And again, states again that we can even do like this me. I would put like Boyle's law, P and V. I go as P arrow up, V arrow down. That's how I would like just like write it basically to make it easier. Yeah. Next. All right. So pressure, volume, constant in Boyle's law. All right, so in Boyle's law, the product PV is constant as long as temperature does not change. If temperature changes, obviously it changes the whole format, because you need to stay consistent to control. So in this right here, pressure 1 and volume 1, 8 atmospheres at 2 liters. There is 16 atmospheric liters. Easy math, right? Multiplication. Do you not see that? Right? See? Right. Basically, PV next to each other is multiplication. 8 times 2, 16. 4 times 4, 16. Got it? Got it. Now this is the formula you want to write down here. Basically saying pressure of 1 instance in the volume of that same instance, the same number 1 instance, is equal to the pressure of a separate instance in the volume of that same instance. If you change it, you will see that mathematics right now. If you don't understand something, make sure you raise your hand and go, Mr. Reagan, I understand what P stands for. I understand what V stands for. Temperature, I don't get it. Whatever it is, make sure you ask, okay? Then I'll let them write it down. I guess. If you have any questions over the internet, just make sure you ask them. Yay, improving. That's good. I mean, approval. That's the only approval I get in my life. Thanks. All right. So, for people who aren't really familiar with mathematics, it's this thing that you should learn. It's called math. I'm going to show it on the ground and right there. No, you get a chance to drop it. The corner is the marker by your feet. I'm just not going to go under to get that. All right, for sure. All right. So, example, if I have that same formula, P1, V1 equals P2, V2. All right, so there it is. Have it all written down. Good for me. Now, I can manipulate this formula however I want. Say, for whatever reason, it gives me a known number. It gives me something. V1, it gives me a number. For P2, it gives me a number. And says we need to figure out what the volume of that substance is. This is exactly what one of your test questions will look like. Okay? It'll give you 3 of the 4 things. You need to take mathematics and change it out. So in this case, I'm trying to isolate this variable. Help me out. What do I do to get this by itself? I said these are multiplied together, right? Yeah, thank you. You divide by whatever you want to get rid of. P2, you do whatever you do to one side, you do to the other. You cancel out P2. So guess what? Your V2 is now equal to this formula here. If I plug these in, and I will get an answer for this, and I'm all happy. That's exactly what they did here. Awesome. Cool. Next. All right. Boyle law breathing. During an insulation, the lungs will expand. The pressure in the lungs decreases. Air flows towards low pressure in your lungs. So what's happening is your lungs are increasing in volume. Pressure, air rushes in. That's how you can suck in air. You know that's amazing if you think about it? As you breathe, you're not like, the only reason you're sucking in is your lungs expand in air. That's to fill in that space. So it flies into your mouth. That's how you breathe. It's not some special magic, okay? It's not like witchcraft or anything like that. Could be. I'll have to watch the video. I think it's tough to watch. But I think it's amazing how that works. Next. All right. During exhaling, getting rid of the exhaling, basically your lung volume decreases, pressure within the lungs increases, air flows from a high pressure to the low pressure outside, so you're constricted and basically pushes the air out. The air wants to leave. Awesome. Cool. Yay. Sorry to be excited about that. The whole breathing thing. It's really cool. Everyone seems to be doing this nowadays. That's almost as popular as Facebook. Almost. All right. And next. And all right, so let's calculate this. Do me a favor. On your own here. Yeah, you. Yeah, you. All y'all. Even the people at home. I want you to do me a favor. I want you to read this calculation of Boyle's law, and I want you to figure out what the answer is on your own. So go ahead and take a piece of paper or whatever you want, put it on your notes, and I want you to try to calculate the answer to this equation. I should say to this problem. And I'll show you how I set it up to make it super simple and easy. So go ahead, you can use your right hand or left hand. Totally your left hand. Totally cool with that. Go ahead and Write it down. First thing you should do is write down the formula. Hey, you're ahead of me, buddy. All right. So let's look at this. What you gotta do is it doesn't matter which one you make P1 or P2. It really doesn't matter at all. You just gotta make sure they stay together. So it says, what is the new volume L if of 8 liters of freon gas initially at 550 mmHgs? We'll just go with atmosphere together. After the pressure is changed to 200 or 2,200 mmHg at a constant temperature. So it gives you P1. Pressure 1 is 550. It gives you the volume initially, which is 8 liters, and it gives you what happens after the conditions change. Pressure went up. What do you think happens to the volume? Okay, so you know what happens. So this number has to be lower than 8. Agreed? Okay. What do we got? Anybody? He's guessing. All right, so let's do this. So I set it up. P1, V1, P2, V2. I need to get volume 2 and divide by P2. I'm just setting up my equation. So now I have my equation finally. Good for me. It gives me P1, what is it? 550. I always put it. So V1 is what? 8. I put it over what's P2? 20 mmHg. All right. Do I see anything that is the same on the same side? Looking at it. Is there anything on the top and bottom of it? Oh yeah, yes, stop. Whatever that is. They're the same. It's just a unit of measure. We don't use a hair stuff, don't worry about it. So basically you just get rid of that. Cool, awesome. Now I only have 1 unit left, liters. So whatever the volume is, it's going to be in liters. So anyone have a calcium negator in front of them? Anyone? Calcium negator? Justin, calculator out, please. Cool. Take 550 times it by 8. Divide by 2200. 2200? Yeah. You saw it like really easy. Alright, so basically volume 2 is now 2 liters. So what happens is the volume decreases and increases. Pretty easy, pretty straightforward. Next. If you guys thought that was easy, then, by the way, there it is, so next. Again, anytime you manipulate it, either decrease the pressure or increase the pressure, the volume is going up and down. Just make sure you know that. Next. Yeah. Oh, on there. Go ahead and click on it. Okay, go ahead and ask the question again. My TA accidentally hit the X instead of the answer button. So do me a favor, either go and ask that same exact question again, and I'll try to make sure it doesn't happen this time. It's all right. All right, next. We're going to skip this one. Okay, do me a favor, go ahead and do this one by yourself right now, and tell me what you think it is. 1, 2, or 3. And if most of the people get this one right, we can skip through a few slides. So spend your time and focus. Write down the formula first. First thing you do, write down the formula. Then, yeah, so we want to do it again. We, most of you guys, when I go around to get this right, we can skip ahead a little bit, which is awesome. The first thing I do, I write down the formula. First thing I do. Second thing I do is I literally write P1, D1, D2, whatever. I write that to the left. And I write down whatever it gives me. One of them is not going to give me the answer to. I plug them all in, and I solve for the variable, and there's the answer. Basically, this is pretty much basic algebraic math. Hopefully. Sometimes word problems are hard, you know? It's the way that sometimes the way they say things, you just you do it.
Mhm.
And if you don't get it, it's fine, don't worry about it. This isn't a test. Okay, I'm gonna walk around, let me know where you're stuck. Right here. I would say right here. So the activity is showing volume and not say the volume, it's right side up. It says the volume, it's volume, and then now the pressure went down, so the volume stays up. Exactly. All right. Here comes a vote. This is our democratic system of government. We're going to vote. Number 1, number 2, number 3. Who thinks it's number 1? Got one vote. One vote for number 1. Polls are closing. Okay, we're good. Number 2. Who thinks number 2? Okay. 0. Polls are closing. Number 3. Some people's not voting. I need you to see your hand. Well, look around. Let's see your hand. Hand, what do you think? Okay. So we got pretty much all but 1. All but 1. Right? Now let's think of some logic here. Okay. Let's first think logic. We know that the pressure is decreasing, which means what happens to volume? Increasing. So if I already know it's 120, it needs to be greater than 120. What is the only answer that's greater than 120? We didn't do any math. Know the concept, no math. Because it can't be the same because pressure's not the same. It can't be lower because we know the idea of the concept. So automatic, move. Number 3, you didn't need to do any math. But if you need to do the math, hopefully you know how to do it now. Skip all the way ahead to where Charles left. Go. Keep going. You'll see it. Oh, we're actually on. We're going to do the elusives next. All right. Okay, now, different dude, same concept, kind of. Okay, this gentleman here, Gay-Lussac's law, basically talks, or it can be Lucid or Lussac, I don't care. Okay, whatever you want to call them, as long as you understand who did it. It's going to talk about temperature and pressure. That is different than we just talked about. What's different? Yeah, we're going to talk about temperature now. Exact same thing pretty much, but we're talking about temperature. So you can talk about plug-in, plug-in, same exact thing. Concept is different though. They're not inversely related. What happens if I increase temperature of, say, what happened in the balloon? What happens to the pressure? It increases. Even the people lying in the class know. Good. It increases. So there's a direct relationship. One goes up, the other one goes up. Good for us. Now we see how much it goes up. That's where the math comes from. Next. Okay, so we're talking about PNT, and Newton's law, the pressure exerted by a pressure is directly related to the Kelvin temperature. Temperature is 400 or 200 Kelvin. By the way, Kelvin is what they use in chemistry, and they use it in physics. You can calculate it out from Fahrenheit and Celsius, but it just gives a choice of it's kind of like this temperature. 0 Kelvin is absolute zero. Technically, it doesn't exist. So absolute, what is, we want to know what temperature is. We want to know what is temperature. Okay. Average kinetic energy of something. If it's 0, it means there's no energy. Therefore, it can't exist. 0 Kelvin never exists. All right. At least one. Okay, so we're talking about. So we look at the formula now. I don't want that formula. Click next. I don't want to put it up. Next. So there's a better one pops up. Give me a second. Oh, it's horrible. Next. See the other. At least that one looks better. Sometimes when I spill power, I mean when I borrow PowerPoint professionally, those teachers don't do a good job with that. That's why I put their name off it so we don't rag on them. You know. All right, so here's that. We got P1, T1 equals P2 over T2. All right, so there's your formula. Same exact thing. Plug and shove. So in this case, it gave you, let's actually go back one. Now that we read that, let's go back one. Okay, so it gives us P1, 2 atmospheres. Good press. So 2. Okay, it gives us T1. By the way, you see right here, I would definitely write down the formula to get it in Kelvin, because it may give it to you in Celsius, and we have to calculate the Kelvin. So know how to go from Fahrenheit, and write this down so you should know this. How to go from Fahrenheit to Kelvin, how to go from Celsius to Kelvin. Google it. So right here is one. You take for Celsius, you take whatever number it is in Celsius, plus 273, and that gives you Kelvin. Fahrenheit is different. I don't know what it is off the top of my head, I'll also just look it up. So you want to make sure again it's in atmospheres and then Kelvin. All right, so it gives me T1, right? 291 Kelvin. It gives me T1, no it does not. That's not my variable. It gives me T2, which is 335 Kelvin. So I'm going to go ahead and do some quick little math and move that up there. So this is now gone up there. The 2 Kelvins drop off. So basically my math now is 2 atmospheres times 335 over 291. What does that equal to? People with calculators or phones with the capability for our calculator function. .30. All right, let's go. So it's what? What are we looking for? Pressure, right? So is it in Kelvin or atmospheres? It's only good. The only thing good is what? So we know it's only one left. Okay, next one. Okay, 2.3 atmospheres. Good job. There we go. Next. Okay, go ahead and do this one by yourself. And again, the pressure on this case is 645 And then you also have your temperature as 128 degrees Celsius. And you add 273 to it, or whatever it is, right? Go ahead and calculate this. I'm going to walk around and see your answer. And if you can all get pretty much close to the same answer, we can pick that again. Good for us. Original Karate Kid. One of the best things. The whole movie. Well, what's funny is I love it when they're doing the crane. Yeah. And it's like, the crane can never be defeated. It can never be like the next movie the guy's totally lost. It's like, apparently he did his research on that one. Kind of gives it away when you're like this for 30 seconds, like what you're going to do. Yeah, fine. Still better than you're going to do. That long. Well, this is what happens when they're supposed to be in high school. No, it's supposed to be in high school, and they did a movie, they wanted him to be in it, and they did it when he shouldn't have been the youngest, but they miscast him, basically. I'm not a Twitter regular. I don't know either, but I heard about it. All right, so this is what you want to do. We're recording it. All right. Everyone have their answer down? Pretty close to it? Yeah. Yeah, right. All right. She's like, yeah. Pulling paper. All right. So get it written down. Go ahead and do some mathematics. We'll give you guys another 30 seconds, and we'll basically have a walk around, see if you have an answer. I'm going to do it up here with you on the board, and this is how I would do it. And if we all see the answer, we get to skip ahead like 10 slides. How often does that mean? 10 slides skipping. I love skipping ahead 10 slides. I want to list the things I want to do. All right. Go ahead and go through. Point to the answer for me. So hey, get some more time. It's easy. Hit the reset on the button. Good go. People on the internet, will you do me a favor? Will you please type your answer into the chat box, please? Yeah. You see, we'll leave right away.
Oh my God, sorry, I lost it.
You guys? 17 pages of paper later, you got the answer. All right. This is the answer. What do we got? I don't have the answer. Good. You don't have the answer. Yes? Okay. No. Good. No. Okay, Okay, that's good. Okay, go ahead and click on it in. I give up. Good. 32 liters. Okay, let's see how we're at. All right, so let's do the mathematics on this. First thing we do, by the way, easier to do. Click next. See if I can stop next. Sorry, the people on the internet will go see it. All right. First thing you do is you write down your formula. P1 over T2. I'm sorry, P1 over T1 equals P2 over T2, right? Right? Okay. Okay. It gives you P1. It gives you T1. It gives you P2. It does not give you T2. All right. So it looks like we're looking at Kelvin, so the answer should be in some sort of a temperature. So let's look next. So go ahead and T2 is equal to 401 Kelvin times 140 over 645. Go ahead and cancel out what you can. So you cancel it out. It looks like the pressure. It equals to 709 Kelvin. We go ahead and put that back into Celsius by minusing the 273. So the answer would be 436 degrees Kelvin. Now, if it asks you for it in Kelvin, I knew it. First, what is it asking for? Make sure it's in Kelvin. Make sure it's in some sort of atmospheric pressure. Okay. Do the math. What is the answer supposed to be? Need to be in Kelvin again? Probably. Again, we're probably going to ask for it in Kelvin, but if you see all the answers are in Celsius, do the quick mathematics. Click next. We're going to do one more together then. Into Charles Locks, do the exact same thing. All right. So this guy, Charles, cool dude, hang out all the time. One of the best BFFs. All right. Two best BFFs, best friend. He also has a beard. Really cool guy. Okay. Didn't have anything to do. So he sat in a lab, and he just said, you know, I'm going to take these air pistons, and I'm just going to play with them. That's what I'm going to do. Just see what happens. You know. So he played with the air pistons, and guess what? He figured out that temperature and volume have a relationship. Pressure got jealous. All right, so we got temperature and volume now. So what do you think happens? If I increase any thing, so I start increasing temperature, what do you think happens to the volume in here? Should expand, right? Now, it should be. I mean, in a balloon it will, you know, whatever. But if it just like is stuck there, that's why this piston now allows it to move. They'll actually allow the piston to push upward on it, so they can actually calculate what that is. So, go ahead and hit next. So this guy, Charles, again, my BFF, don't make fun of this dude, okay? Cool guy, all right? My best bud. He's been dead for like 100 years, but hey, we hung out. We hung out, yeah, you know, it's just, like, yeah. You know, in the air, I come visit, it's really nice. It's one of the voices in my head. Just one of the voices in my head. All right, so Charles' law, Kelvin, the temperature of gas is directly related to the volume. P and N are pressure, basically constant. When the temperature of a gas increases, the volume should also increase. Now, this isn't a set piston. It's increasing the temperature. It's allowing the piston to be able to push upward, so it's going to increase it. This is the exact same concept as the last one. The only difference is we added what? Temperature and volume. Yay! Basically the same exact thing. The formula is identical, except for you change those out to an S. Let's see if there's another one right off. Yeah, there it is. Here we go. Yeah, nicely done on this one. Whoever I stole this. I mean, whoever I borrowed this from on the internet, and I give them total credit, whoever that person is. Good job to that person. I forgot this is on YouTube. They might actually hear me. All right, V1 over T1 equals V2 over T2. Exactly the same concept. You plug in the answer, plug the numbers into the right location, and do your mathematics. So next. 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 Okay. So let's look at this. A balloon has a volume of is at 785 milliliters. At 21 degrees Celsius. Celsius, what's the problem? Yeah, change it, right? What do I got to add to that number? Damn. That is probably correct. It's 100% correct. So if the temperature drops to 0 degrees Celsius, so there's a change in the temperature, what is the new volume? What is it looking for? V2. So set up your equation, change your Celsius to Kelvin, it gives you both of those. Go ahead and set up your mathematics. Next. Okay, so we go ahead and do so. So V2 will be equal to don't mind me, my mouth's not working today. I need to return it. 785 milliliters times 273 degrees Kelvin divided by 294 Kelvin, you will get the answer of 729 milliliters. Temperature went down, guess what happens to the volume? Went down. So it's directly related because this is the problem. Like the first one I showed you guys was pretty straightforward, right? Like I said, okay, what's the answer? You need to do math. It's just like, okay, they're inversely related, so it's not equal, it has to be greater than. Problem is when you start doing directly related stuff, it's like, well, how directly is it related? Like how close is it related? Is it a little temperature makes it go, you actually have to do the math on the last two for Gailey, Six, and Charles. So unfortunately, they like math. No one likes them math. I'm trying to rethink the friendship I have with them. I'll make me and Charlie be a wrong anymore. I realize how much math you know. So next.
Do you think oil something when we got away?
I had it. All right. Okay, go ahead and do this equation yourself. The answer is either 1, 2, or 3. And then we'll go through and do our democratic. And by the way, people on the internet do as well. Want to go to type in 1, 2, or 3, and then we'll see where we're at. So go ahead and, again, write down the formula. Write down what each one of those numbers in the word up there, what it represents. Change Celsius to Kelvin if needed, and then plug your shove you get in. Focus. So any distractions you put. Focus. Write down the formula. Done. Very science stuff. I mean, science is awesome. You should learn it. All right. Okay, raise your hand and need a little bit more time. You good? All right, cool. Let's do our democratic. All right. Let's drop it on the ground. All right, good. Okay, so we have number 1, number 2, number 3. We have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 people in the class. Cool, that's important in a second. Who thinks number 1 is the answer? I'm seeing kind of one answer. 1? Kind of? Okay. 1. Who has number 2 as an answer? 1, 2. Let me see. 1, 2, 3, 4, 5. Your hand up. 6. She's like, I don't know what it is. 6. So what about number 3? 1. Okay, this is 2, 3. This is where I've come into a problem. There's 12 people in the class, and 10 people voted. 2 people didn't vote. Which one do you want? Which one do you want?
Let's do the 6.
The 6 is there more people?
Yeah.
Plus 1? What do you want? Hang out a little. Oh, did you? Watch one and see. Was it like this? Oh. Alright, so it looks like we have more people for number 2. Alright, so let's do the math. Actually, hit next. You probably already done it. Alright, so it says it was number 2, 170 degrees. The way they got that is they went ahead and took the temperature, changed it to Kelvin, 291, times it by 640 milliliters, then divided by 420 milliliters, which equals 443 Kelvin. They really like it in Celsius because whatever. So you have to minus out your 273 and get your 170 degrees Celsius back. That's how they got it. We'll write that down. Okay, remember, before you guys leave, I'm going to have you guys here to do it.
No, I'm going to take it around.
Okay, so you're going to take it around. Have you guys sign a piece of paper? It just says that I get all your money when you get over. It's not a big deal. Alright? No, I'm just kidding. What it is, it's basically saying that you came here live in person for the requirements for if you happen to have a D or an F, so you don't get in trouble from me. So make sure you sign in. You also, by signing in, will receive the credits for your essential questions. And for the rest of y'all on the internet, and the rest of the people that are going to be watching this via YouTube, please answer the question inside the Dropbox under the proper week. Have a good rest of the day. Bye.